Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we will discuss about the viscosity of a fluid. What do you mean by viscosity? So viscosity actually defines viscosity of a fluid is a measure of its resistance to deformation at a given shear rate. Okay, or we can say this is the resistance of a fluid which is being deformed by the application of shear stress. Or we can say it is a measurement of resistance to a fluid as a result of intermolecular cohesion. So these are the few definition of viscosity is there. So what did it mean by resistance to deformation at a given shear stress, given rate, or resistance of a fluid which is being deformed by the application of shear stress? Based on the definition, we'll do the one derivation, small derivation regarding this viscosity. So let me tell you some other examples of this, then we'll go for the derivations. And different fluids deform at different rates under same shear stress. Okay, or we can say for a liquid, it corresponds to the informal concept of a thickness. So this is one very easy things to remember, the informal concept of thickness. And the value of viscosity of for water is 0.001002 kg per meter second, and for air is 1.8 into 10 to the minus 5 kg per meter second. So the viscosity of water and air is most important because you need to know the basic standard liquid for a fluid, water and air, and the unit for this is kg per meter second. Okay, and even sometimes it will be given in pascals, and some other units also it will be given, so that also need to be remembered. Now few examples I have taken here. First one is the water, and another one is the engine oil, and another one is the syrup, and this is one tar, and this is honey. So these are the different liquids are there. If you see, all the liquids are having different viscosities, or you can say the thickness of the liquid. Okay, now if I see the water, the normal fluid which you are use daily basis, the thickness of this water is very less compared to the other liquids. Even if I compare the engine oil to the water, then I can get some more thickness of this liquid than the water. Similarly, if I take some syrup, it may have more thickness than this engine oil, and similarly tar, it will have more thickness than the this syrup. And honey is quietly thicker than like water and engine oil, because these are the things depends upon their quality and what kind of methods to prepare this, so that depends. Anyway, these are some examples of this fluid of different viscosities, and the viscosity values of for different fluid also here I have mentioned, like hydrogen, air, gasoline, water, ethylene alcohol, mercury, SAE, glycerin. Okay, and the values of viscosities for different fluids are given. Now let take an example of these different liquids, and these are the different liquids. Let keep in the water tube or glass tube. Okay, take some different liquids and pour in the glass tube, and after that just we'll do a small experiment. All the tubes like try to bend little bit with an angle of 45 degree or 60 degree, and try to pour the water or ethanol or honey which is there. Now if here I have taken some, like, suppose this is the water is there, and some ethanol is there, and let's say this is the honey, and the sludge and slurry a little bit both are looking like similar, but some liquids are there inside this tube. Now if you pour this liquid, okay, with some bending, then you can see the water is coming a little bit faster than the other liquids, because as I told you, this depends upon the thickness of the liquid. So based on the thickness and based on the viscosity of the fluid, it flows in the pipes or in the tubes. So you can see the liquid of water will become very fast than the others. And similarly, if you go for ethanol, slightly more viscous than the water, so it will come slightly less faster than this water. And similarly honey, it will have some more thicker than these other liquids, so it will come a little bit less. And this sludge and slurry or paste kind of items, it is very difficult to flow. So it required more shear stress to be flows. So this is about the definition of the viscosity. Let's try to understand what is this resistance and deformation and this shear rate. Okay, how it denotes this definition of the shear stress or viscosity. Yeah. So as I told you, with a given shear rate, if the liquid or fluid is moving or it's showing some resistance to be without any deformation, like suppose let's take this is the plate is there. Okay, this is the plate which is fixed, and the liquid is or there, suppose this is the liquid layer, and in this liquid layer is supposed to be a let apply some kind of shear stress here, that is tau, or if you apply some force also, that will be also applicable. And now here the shear stress which is applied on the upper layer of the fluid, you can see if the fluid is having more thickness or more thicker or more dense fluid, you can say, so it will resist up to some time. This what is the shear stress applied here, it resists up to some time, or you can take some force also. Okay, the force which is applied here, so based on the molecular bonding of this liquid, it will resist up to a limit. Okay, so at what point it is going to deform, that means it's at what point it is going to breaks its molecules. Okay, that indicates the viscosity of the liquid. Suppose if the same thing will be applied for a solid, okay, a solid item is there, and this is the fixed things is there, and you are applying some kind of force here, then obviously you can see very slight, very small deformation will be there, like means very small movement of this solid will be there. Okay, and that is fixed only at a time, only single time. It is not, it won't continuously deforms. Okay, so only very small thickness of movement will be there for the solid. That will be depends like at what force we are applying here, at what force we are applying here. So that depends. So this fluid indicate that deformation of a fluid indicates the viscosity of a fluid. So if I consider the force here, that force will be, the force will be directly proportional to the area of the position where it is applied, and this movement, this change in, how much changes happened, this angle, okay, that is shear strain actually. So that force also directly proportional to the shear strain, or we can say this is the velocity gradient which is deformation happened. So that is actually du by dy. So I'll tell you what is du and dy. Now du is the change in velocity. Now as per the definition, if you see the resistance of a fluid which is being deformed by the application of shear stress. So here if we are applying the shear stress here, now in this also we can get the shear stress. Let me combine both this equation. So we'll get what, F directly proportional to area into du by dy, and if F that area part I'll take this side, then F by A directly proportional to du by dy. So A by A, force by area, is nothing but stress. So that shear stress is denoted by tau. So tau is directly proportional to du by dy. Okay. Now the next thing is this tau equal to du by dy, and we can write, if we remove this proportional symbol, then we can get tau equal to mu into du by dy. Okay, this is actually known as Newton's law of viscosity. Okay, let's come to here, we'll see here. So this tau is nothing but the shear stress which we are applying here. Due to the application of shear stress, how much deformation happened in the fluid. Okay, and due to this deformation, now see, if you consider two different consecutive layers of this fluid, now this is one layer and this is one layer, and the deformation will be formed like this. Okay, if I close this one, you can get like this. So this is the velocity boundary. This is the velocity boundary of the fluid. Now at this wall, we won't get any kind of velocity, that is zero. Velocity will be zero at this boundary layer, because, and that is also called as a no slip at the wall. No slip at the wall. And this curve you can see. So these are the velocity difference. If I plot the velocity difference in the vertically, as vertically the length increases, your velocity also increases now, see. Okay, so if I consider two different layers, one layer at velocity, suppose here, suppose this is the layer u velocity, and if I go to the next layer, that will be u plus du. That means some small changes in the velocity at the next level. That means some increment in the velocity happened with some distance of du. So with change of distance, the velocity also changed. So how much changes happened? Now that is du happened. Initially du, then here it is u plus du. So how much changes happen? Now u plus du minus, if u, then we'll get the du. So the changes of velocity, that is du. And with respect to distance, that is also called as the velocity gradient. This is called velocity gradient. Okay, even sometimes also it is called as a shear strain, that how much deformation happened here. Okay, so that also will be considered. Now this is the equation for the Newton's law of viscosity, actually called. So here tau is the shear stress, mu is the viscosity, and du by dy is the velocity gradient. Okay, so the fluid which obeys this Newton's law of viscosity, then it is called as the Newtonian fluid. If the fluid do not obey the Newton's law of viscosity, then it is called as the non-Newtonian fluid. Okay, so few examples of this Newtonian fluid and non-Newtonian fluids are given here, like air, water, oil, gasoline, alcohol, and kerosene and glycerin. Okay, and some mechanism of this viscosity also there, like for the gases and for liquids. As we know that gases is a compressible, so the transfer of intermolecular molecular momentum is there, and here the liquid, the cohesion and momentum transfer will be there. The cohesion in the sense the bonding between the similar kind of materials. And for gases, the viscosity will increase as the temperature increases. If you increase the temperature, then viscosity of the gases will be increased. And similarly, viscosity increases as pressure increases. So both, proportional, like viscosity, temperature, and pressure both. But in the liquid case, if you see, our viscosity will be decreased as the temperature increases. Okay, if you increase the temperature of the surroundings or any liquid, then we can see the thickness, as I told you, the thickness of the liquid is going to decrease. So that indicates the viscosity of the liquid, which is going to decrease. And relatively independent of pressure. So because we know it is not a compressible, it is incompressible. So very less dependent on the pressure. This is about the fundamental mechanisms for the gases and liquids. Okay, this one plot is there for viscosity and temperature for liquid. If I plot that one, suppose if this is the temperature is there and this is the viscosity is there, then we can see as the temperature increases, your viscosity value will be decrease like this. Okay, for different kind of liquids, you can plot the measurement like this. So temperature you can see, the degree centigrade will be there, and your mu will be in the kg meter per second. You can put it, or you can keep in the Pascal also. Okay, and one more viscosity is there, that is kinematic viscosity. So till now what we have discussed, that is actually called as the dynamic viscosity. The viscosity is nothing but that is dynamic viscosity, and that is another one part is there. This is kinematic viscosity, and your dynamic viscosity is indicated by mu. This is mu, and the kinematic viscosity is indicated by nu. This is nu, nu, and it's the ratio of viscosity, dynamic viscosity, to the density of the fluid. So what viscosity we got here with respect to density, we'll get the kinematic viscosity. It indicates the unit of this is meter square per second. And if you see, the value of this water also given 1.14 into 10 to the power minus 6 meter square per second, and for air 1.46 into 10 to the power minus 5 meter square per second. So these are the small examples of this given. And sometimes this viscosity value also will be given given in the Stokes or some other units also will be given. So in that time we can change its unit from Stokes to meter square per second. For that also value will be there, 1 Stoke equal to 10 to the power minus 4 meter per second. So 1 Stoke equal to 10 to the power minus 4 meter square per second. Okay, so this is the definition of viscosity and types of viscosity and the Newton's law of viscosity. So I hope you understood this lecture. If you are having any kind of queries and doubts are there, you can give a comment in the comment box. Thank you all.